Hey everyone, welcome to chapter 34. So in this chapter, we're going to be talking about populations and communities and how they work together. We're also going to learn about ecology. So when we say ecology, this is the interactions between the different populations of organisms with each other and with their environment that they live in. And so we study ecology to develop models that explain and predict population abundance. So what is a population? A population is a group of organisms of the same species that inhabit a particular area. And the community then would be all populations of all different species that are in that area. So if I'm thinking about my home and I want to use my home as an example, I could say there's a population of humans that live in my home, a population of dogs that live in my home, a population of guinea pigs that live in my home. So the community would be then all of these populations together within my home, right? And the ecology, studying the ecology, would be the interactions between the humans, the dogs, and the guinea pigs and the environment. So an ecosystem then is your community, so all the populations, and the physical environment, including both abiotic and biotic components. So abiotic are non-living components, whereas biotic are I say living components. But so you can think of abiotic. I want to make you understand. When I say biotic, it's things that affect the life. Like competition for food would be a biotic component, whereas an abiotic component would be something that is like the weather is abiotic, okay? And so in our house, we have our ecosystem would be all of us together. The abiotic components would be things like the environment that we live in, the rooms that we live in, right? How we have split up our property so that all the different communities can live and cohabitate. Biotic things would be like sharing of food. So we don't really share the dog's food because that'd just be really weird. Though they do make some really good smelling dog cookies now, but I wouldn't share them. But dogs love to share our food, right? And so like at Turkey Day, Thanksgiving, our dogs were all under the table waiting and hoping that we would drop a piece of turkey or, give them a little bit of potatoes for their, adorableness. So that would be that biotic component again. And I'm going to change the color of my pen because, like I always say, I like to have, I don't like red for when I'm writing on here. So here is just an ecological organization diagram. Here you have an organism. Organisms make up species. When we have multiple species of the same species in the same area, we have a population. Communities consist of multiple different species, so that's what you're seeing here. And then here they're just saying, okay, the abiotic and the biotic components, so the weather, the protective nature of the plants, the predation of these larger fish onto the maybe smaller fish, okay? So each population has its own growth pattern. And growth patterns, population size, can change depending on how many live births we have versus deaths we have, and that's called our growth rate. And these are going to change depending on both the living and non-living, the biotic and abiotic factors that affect us, okay? So if you have a population of organisms, and the population has 1,000 members, and right now you have a birth rate of 30 live births per year, and you have a death rate of 10 deaths per year. You would take the live births minus the deaths, subtract those, and then you would divide that by 1,000, the total population, and you would get a percentage. Multiply that by 100 and you get that 2% per year would be the growth rate. Growth rates can be positive or negative. You can actually have a negative growth rate where your growth is actually decreasing each year because maybe you have more deaths than you have live births per year. So let's try one. So there's a population of Wendtellians living at Carl Sandburg College. There are a total of 20,000 individuals in this population. On average, they are producing 20 new Wendtell babies each year. They tend to lose about 12, wow, I can't speak today, Wendtelderly each year. So what is the growth rate? So at this point, I would pause it and try to do this on your own. And so I'm assuming you're paused it, and now we're going to go back and we're going to go to the next page. So now let's look at what we got, okay? So I'm going to kind of go over what we would do. We have 20,000 Wendtellians. That's the total population. We have 20 live births, Wendtell babies, and 12 deaths, Wendtelderlies, okay? Take the birth minus the death, so that would be 20 minus 12. Divide that by the total population, 20,000. And that gives us some number that we multiply by 100. And that gives us our percent, okay? So if we do this, this is 8 divided by 20,000 equals some number. Okay, I'm not going to use x as some number. I'll just leave it as a blank times 100. That's going to actually give us a number of 0.04%. So this is a positive growth rate, okay? Now, let's look at that same population. They went through a life-altering event. Let's just say that COVID-19 wiped out 25% of the entire population. So Wendtellians are very affected negatively by COVID-19. And so now their population size has changed, but this has also changed the numbers of deaths yearly due to the decrease, since the majority of the population that was killed off by the COVID-19 were the elderly. So the number of births are still the same. There's still 12 births, but now we only have 8 deaths. So how is our growth rate going to change? So again, pause it here. And I'm going to go through and write down the information. So now we have still 12 births minus 8 deaths. Okay. But we have 25% smaller of a population, so we only have 15,000 equals some number times 100, which is going to give us, I'm just going to do this on my handy dandy calculator, 4 divided by 15,000 equals 0.000266667. Multiply that by 100 and I get 0.026% growth rate. Okay, so the original population was 0.04. Now we've decreased that positive growth rate. It's still a positive growth rate, but it's decreased. Oh, you know what? I changed that number too. Let me go back because I see that I made a mistake. Do you see where I made a mistake right here? Number of births is still 12, but the actual number of births should be 20. So let's change this to 20. So now 20 minus 8 is 14, right? No, 12 is 12. So we have 12 divided by 15,000 equals 0.0008 times 10 or 100% is a 0.08% increase. That makes more sense. Okay. So this number is the wrong number. That number is actually was the original number of deaths, but we've decreased the number of deaths to 8. The number of births is still the same, which is 20 births per year. Okay, so if we have 20 births per year and now we only have 8 deaths per year, we have increased the number of lives being produced. And the whole population has decreased, so we're dividing by a smaller number, which gives us a bigger per capita growth rate. So hopefully this makes sense, and you can then use this information to answer other questions about other unique aliens that we might find, or fish people, mer people. So I'm going to stop here and we'll talk about biotic potential in the next chapter or in the next video. So biotic potential is the maximum population growth under ideal conditions. And so we'll talk about different things that can influence that biotic potential in our next video. Bye.